So let's learn the next topic. So there is a situation with refraction is that when an object is lying inside a denser medium and it is being viewed from the from a rarer medium, the object position will its actual position will be different from its apparent position. Let me give you a sense of this. If I have a vessel here of negligible thickness and there is some liquid of absolute refractive index N2 is filled up to a height h, and an object is lying at the bottom of the vessel, and the observer is outside the denser medium, it is in the rarer medium. So I have written in the first case here. Second case also we will learn. So the first case is that when the observer is in the air and the object is in the medium. So if this is the object O and the observer is looking at this from the outside, then what will it see? It will see that first of all there will be one ray which will be going straight without any kind of deviation. There will be the another ray, there will be infinite number of rays, but let us consider one oblique ray. So this is an oblique ray which will undergo refraction here, and after refraction, as is the rarer medium, it moves away from the normal. In the denser medium, the ray moves towards the normal, and in the rarer medium moves away from the normal. So this is how, so this is the angle of incidence and this is the angle of refraction. So if here is the observer looking at the object, then the observer will find that the object is not located at O, rather it is located here. The image is presented here. This distance is called the apparent position. I am denoting it by h dash. Okay, so you can see this image is completely virtual, right? So let us see, is there a relation between these two distances, apparent position and object real depth and apparent depth and refractive index or not? We can easily establish it. So as I am saying, so if this is I, this is R, can this also be I, because these are alternate angles? And if this is R, this must also be R, corresponding angle. Very simple derivation. And let me name this position, this distance from here to here, let me name this as B. You will see why very soon. Now first assumptions is that the angles are small, very small, so small that sine of I equivalent to I equivalent to tan of I, and we can write this. So whether you take sine I, whether you take tan I, or you take I, all will be equivalent only, equivalent, not equal. So tan I would becomes now B by H, and perpendicular, this is the perpendicular here, this distance is the perpendicular by base. Similarly, sine of R equivalent to R equivalent to tan of R would be equal to, again, perpendicular by base, this time base is H dash, this should be B by H dash. Fine. Now using Snell's law, sin I by sin R will be equal to, remember always in the numerator I have told you earlier, it will be the second medium in which the ray is going into. So in this case the second medium is N1, which is air. So this one must be N1 by N2. So I can now write sin I are equal to B by H divided by B by H dash is equal to Remember n1 by 2, that means the ray is going from 2 to 1. So BB will get cancelled and we can write H dash by H is equal to 2 n1, but 1 is the 1, we can write like this, no, 1 by n2. Why 1? Because n1 is equals to 1. For air, refractive index is, absolute refractive index is 1. Therefore what we can write? Therefore we can write n2 is equal to H by H dash, that is real depth by the apparent depth. Apparent depth. Okay. Now, what do you think? How much is this distance would be? How much do you think this distance? And what will you call it? Let's say name this by delta H. This delta H is called the normal shift. So delta H would be H minus H dash. H is how much? So from this relation, H dash can be written as H minus, because H is my known quantity, right? So H by n2, which implies H is equal to 1 minus H, 1 minus 1 by n2. Understand? So this is the normal shift. Clear? So this is the situation when the object is in the denser medium and the observer is in the rarer medium, that is, let's say in air. Clear? Now let us go to the next scenario. When the object, let's say, take this situation now. This is the interface which is separating the two medium. Now we are going to consider that the object is in the rarer medium and the observer is in the denser medium. Fine. So to do so, let's say here is the object. So this is a ray. This is a ray coming from the object, because if the ray comes from the object, which will go to the observer's eye, and then only observer will have this sensation of that it is looking at the object, right or not? So this is the normal now, and here is the observer, right? So for the observer, the object is lying where? The object is somewhere. I have to extend it. So if I extend it, the object lies somewhere. This is the image, right? So where do you think the angle of incidence in this case? The angle of incidence will be, this one is the angle of incidence. Which one is the angular refraction now? This one must be the angular refraction. Let us complete this diagram now. So if this is I, this must also be I. If this is R, again this one must also be R. Now this is our B, okay, and this is H, and this must be what? H dash. Note, at this situation the object seems to be long, appear more lengthy compared to its original dimension. It is located far, right? For example, imagine you are diving, you are inside a pond, and from the pond there is a half pole, we will do this kind of, I will explain you this topic, I will explain you with the help of a numerical, then you will understand this. For now just learn the derivation, and then I will teach you through a numerical to elaborate this more properly. So now what do you think will be, so this is n1, this is n2, n1 I am considering air, so it will be equals to 1. So now again using the same assumptions that sine of I equivalent to I equivalent to tan of I must be equals to how much? Sine of I would be how much? Perpendicular, tan of I would be how much? Perpendicular by base. The perpendicular is again b by h, and sine of r equivalent to r equal to tan of r equals to, what do you think would be tan of r? It would be b by h dash, b by h dash. Using Snell's law I can write sin I by sin r will be equal to how much? B by, it would be now, so now the ray is traveling to what? From n1 to n2, so it should be n2 by n1, so implies sin I would be b by h, and sin r is b by h dash equal to, so implies bb get cancel, h dash by h is equal to n2 by n1. So if n1 is air, then n2 is equal to h dash by h. What does this mean? In this case it is what? Apparent depth by the real depth. So n2 would be equals to, I am writing AD means apparent depth by the real depth. When it is apparent depth by real depth? When do you think it will be apparent depth by real depth? In this case the apparent depth by real depth will be when the object is in the rarer medium and the observer is in the denser medium. An example would be when a fish is swimming inside a pond, or when you are diving inside a pond and you look at a pole whose some portion is inside the water and some portion is out of the water. So if you look at the top of the pole, you will see the pole is a little bit long other than its actual length. So these are the two situations of real depth by apparent depth. So we will get more elaborate on this through in my next video, where I will do some few numericals on this to elaborate both the concept. Okay, thank you.